ran anim. Well, that's the way we say hello in Micronesia. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of physics. Now, children, this is KP Rohi Waterfall, Pohnpei, Micronesia. To get to this waterfall, you need not trek up a steep cliff, but you can go walking on a brick pathway. Here, you will get to see small cascades of natural basalt pyramids. Make sure to have the Micronesian desert Uter, and also to tell all the people of Micronesia ran anim. In this note, children, I'm going to start off this lecture of current electricity, where first we'll be looking up the formula that we've dealt with till now, and after that we'll be dealing with some numericals. Now, children, the two formulae that we've dealt with till now are like this. First, we've talked about any charge Q to be equal to n times of E, where n is the number of electrons and E is the charge of an electron. After this, we've discussed the next formula to be the current I given by the charge Q divided by time. Right? So using these two formulae, we will now be discussing the sums. And now the first sum for you people is this. Quickly give it a try, after which I'll be discussing the sum with you people. Right. Now let's discuss the sum. Calculate the number of electrons constituting 1 coulomb of charge. So here we've been given the charge and we've got to find out the number of electrons. Now, in order to do the sum, first we'll be talking about the formulae which is going to be employed. That is, if you talk about the charge Q, you know that the charge Q is equal to N into E. Now here, children, we've been given the charge to be 1 coulomb, so we will write it to be 1, and that's equal to n, which we do not know. That is the number of electrons to be multiplied with the charge of an electron, which is 1.6 into 10 raised to the power minus 19. Now we will make n the subject of the equation, and that will become 1 upon 1.6, and further this is going to be multiplied with 10 raised to the power minus 19. Now remember, children, here what we do is use a formula. That is, if we talk about a raised to the power minus m, then that can be written as 1 upon a raised to the power m. That means if the power of a number is negative, then if it is taken to the denominator, its power will become positive. Similarly, if the power of a number in the denominator is negative, if it is taken to the numerator, its power will become positive. So here, as such, what we can do is we have this 1 upon 1.6, and if we take this 10 raised to the power minus 19 to the numerator, it will become 10 raised to the power 19. That means the negative power will become positive power. Further, next what we do is we will shift to decimal, so this will become 10 upon 16, right? Then further, what we can do here is we can keep 10, right, and we can add the powers, because 10 can be written as 10 raised to the power 1, and you know another rule that if you have a raised to the power m which is multiplied with a raised to the power n, then that becomes equal to a raised to the power m plus n, right? As such, here the powers will get added and it will become 1 plus 19, that is 20, and 16, children, can be written as 4 into 4. Now what is the benefit? The benefit is this, that if you talk about 1 upon 4, you know that it is 0.25. Obviously you can divide and check it too. So here we have 0.25 which is multiplied with 0.25. Now to quickly show you, if you have 1 upon 4, you can write it to be 0 point, as it does not go in 1, right? Then obviously there'll be a 0 here, so it will become 10. Now 4 2s are 8, and then further you have 2 remainder when it becomes 20, right? 4 5s is 20, so this will become 0.25, right? Now, children, as it is 0.25 into 0.25, what we can do is we can shift 2 decimals here, right? And then it will become upon 100 here also, and here also it will become upon 100. Now 25 and 25 will become equal to 625, right? And that further is multiplied with 10 raised to the power 20, right, divided by 10 raised to the power 4. Now remember this, children, if we have some a raised to the power m which is divided by a raised to the power n, then that becomes equal to a raised to the power m minus n. So similarly, this is then going to become equal to 625, right, into 10 raised to the power 20, right, from which 4 is going to be subtracted. So it will become equal to 625 into 10 raised to the power 16, and this can become your answer. Although in physics what we do is we just keep one number before the decimal point and the rest are after the decimal point. As such, if you want to write this, you can write this as 6.25 into 10 raised to the power 18, because these two powers of 10 when multiplied with 6.25 will give you 625. Now this, children, is going to become the final answer. I'll just quickly discuss this once more. In the question, you've been given here that you've got to calculate the number of electrons which constitute 1 coulomb of charge. For this, the formula which is going to be employed is Q is equal to N into E, where N is the number of electrons to be found in the question. So as the charge is 1 coulomb, so we have 1 to be equal to N into the electronic charge, which is 1.6 into 10 raised to the power minus 19. Now further, to make N the subject of the equation, we require to take 1.6 into 10 raised to the power minus 19 to the denominator. Then when we shift decimal, it becomes 10 upon 16. And this power of 10, which is minus 19, it goes to the numerator and has positive power, because if you have a raised to the power minus m, it can be written as 1 upon a raised to the power m. So as the power of this in the denominator is negative, when it goes to the numerator, it will have positive power now. Next, now we can write the power of 10 to be 1 plus 19, that is 20, because a raised to the power m when multiplied with a raised to the power n will become equal to a raised to the power m plus n. So 1 plus 19 will become 20 thus. Next, 16 can be written as 4 into 4, and as you know that 1 upon 4 can be written as 0.25, so this will become 0.25 into 0.25 coming to the numerator. Next, we can shift to decimals, and then we have upon 100 for both of these fractions. Next, we have thus 10 raised to the power 2 into 10 raised to the power 2, that will become 10 raised to the power 4. And as we have 10 raised to the power 20 divided by 10 raised to the power 4, we have this rule: a raised to the power m divided by a raised to the power n will become equal to a raised to the power m minus n. So we have 20 minus 4, that is, it will become equal to 16. Now further, next, 25 into 25 will become equal to 625, which is further multiplied with 10 raised to the power 16. Now to get to a better answer, what you do is before the decimal point, keep one digit, right? And in order to do that, you can write this as 6.25 into 10 raised to the power 18, because these two extra powers of 10 will make it 625 as earlier the answer was. So this, children, is the final answer to this question. Is everybody clear about this? Aryan? Tanish? Sure? Good. Now, children, after this, we will be discussing the next question, that is this. Again, children, I'll be giving you 10 seconds for trial, after which I'll be discussing the sum. Right. So here, children, in the question you've been given a current of 0.5 amperes is drawn by a filament of an electric bulb. So you've been given the current. This is what we can register here, that the current has been given to you as 1.5. After this, I'm sorry, it is 0.5. After this, you've been given that electric by a filament of an electric bulb for 10 minutes. So the time has been given to you to be 10 into 60. This is in seconds now. Find the amount of electric charge that flows through the circuit. So you got to find the amount of the electric charge. So Q is something that you got to find out in this question. Now again, children, we'll be talking about the formula. If you talk about Q, then Q is equal to I into T. Right? So this is the formula. From where has this formula come? That is because if you talk about I, then I becomes equal to Q divided by T. So if you want to make Q the subject of the equation, it will become I into T. Now using this equation, what we are going to do is we will find out charge Q. So that will become equal to the current, which is 0.5 amperes to be multiplied with the time, which now has been converted to seconds, as 10 into 60. Now for the children, we will shift to decimal, so this will become upon 10. 1 part of 10 from the numerator and from the denominator will get cancelled. Now 6 5s is 30, so this will become equal to 300 coulomb, which will then become your final answer. So pretty simple sum. I'll just quickly discuss this. In the question, you've been given that there's a current of 0.5 amperes which is being drawn by a filament of an electric bulb for 10 minutes, right? As it is 10 minutes, and minutes is not the SI unit, so we will convert this to the SI unit, that is seconds. So we have 10 into 60 in seconds, right? The charge is what has been asked to you. So charge will become equal to current into time, as current is equal to charge upon time. So further children, next what we will do is we talk about this current, which is 0.5 amperes, and multiply it with the time, which is 10 into 60. So further, on shifting decimal, 10 will get cancelled, 6 5 is 30, so it will become equal to 300 coulomb, which is the charge. So is this clear? Sure? Kshitij? Really? Very good. Okay children, after this I have this as the next sum. Quickly give it a try. Right. So in this question, children, you've been given in a conductor 6.25 into 10 raised to the power 16 electrons flow from an end A to end B in 2 seconds. Find the current flowing through the conductor. So again children, the same formula that we employed in the last question is going to be employed. That is, if we talk about the current, then that is equal to the charge divided by time. So here what we do is, as we've been given the number of electrons, so the formula for charge is being used, that is Q is being talked about N into E, and you know that the value of E is 1.6 into 10 raised to the power minus 19 coulomb. So as such, if you talk about the charge, right, so in place of just directly using Q, we'll be talking about N into E. Now children, here what has been given to you is the number of electrons, that is N has been given to you to be 6.25 into 10 raised to the power 16. Further, you've been given the time to be 2 seconds, right? And then we've got to find out the current. So as you know that the current is equal to charge upon time, so here for charge we'll be talking about N into E. N is 6.25 into 10 raised to the power 16, and this is going to be multiplied with the charge of an electron, that is 1.6 into 10 raised to the power minus 19, and in the denominator you will have the time, which is 2 seconds given to you. So further children, here what we do is we shift a decimal from 1.6 and we shift 2 decimals from 6.25, and thus we have 10 raised to the power 3 in the denominator. Next, now what we do is we can now multiply 625 with 16, but in a different way. 25 into 25 is 625, you know, right? And further 16 can be written as 4 into 4. So when we multiply this way, we know that 25 into 4 is going to be 100, and 25 into 4 is again going to be 100. Thus that will give you 100 into 100, right? And further we will now be checking out the powers of 10, which is 10 raised to the power 16, and to that is going to be added a minus 19, right? That is because when we talk about the formula a raised to the power m, when multiplied with a raised to the power n by exponents, we have a raised to the power m plus n. So that is why, keeping the base to be the same, the powers are going to get added. Next, now what we do is we get to our final answer. Now we have 10 raised to the power 4, which is going to be added to 16, right? And from which 19 is going to be subtracted. So this is going to give you 16 plus 4 is 20. 20 minus 19 will be 1. That means 10 will become, in amperes, the final answer. So here children, I'll just quickly be discussing the question. In the question, you've been given in a conductor 6.25 in 10 raised to the power 16 electrons flow from end A to end B in 2 seconds. Find the current flowing through the conductor. So if you require to find out the current, then current is equal to charge upon time, as you've been given the number of electrons. So the formula for charge is going to be N into E. Now the number of electrons is 6.25 in 10 raised to the power 16. That can be registered, and the time taken, 2 seconds, can also be registered, as I is equal to Q upon T. So multiply the number of electrons with the charge of an electron and divide it by the time. Now when decimals are shifted, so you have 10 raised to the power 3 in the denominator, Now 625 can be written as 25 into 25, and 16 can be written as 4 into 4, and further you can add the powers of 10 as 10 raised to the power minus 19 plus 16, which will give you 16 minus 19. Now here, as you have 25 into 4, which becomes 100, and 25 into 4, which becomes 100. So 10 raised to the power 4 is also there, to which 16 minus 19 will get added, and thus you have 20 minus 19, which is 10. Thus 10 amperes is the current which is being talked about. So are you all clear about all of this? For sure. Sangam, Rakesh, Monica, really? That's good, children. So make sure you do these numericals all over again and practice them well. Meet you people in the next lecture. Till then, bye.